Welcome to Java EE development with NetBeans 7. In this section, we're going to talk about the NetBeans editor and some features that allow us to write code fairly quickly. We won't go into Java EE development right away. First project we will see is going to be standard Java. However, everything we cover in this lesson will be applicable to both standard Java and Java EE projects. We're going to see how to create a Java project. Then we'll see some time-saving features from NetBeans like code completion, code generation, and code formatting. Let's go ahead and create a new project. We can hit Control-Shift-N, say File and New Project. We do want a Java application, so just click Next. NetBeans intro, give it a name, and then let's change this package to something more realistic. All right, click Finish. And here's a new project. A class with a main method is generated automatically. Before moving on, I would like to mention that we're going to be talking a lot about keyboard shortcuts. So there is a built-in reference for keyboard shortcuts that comes with NetBeans, where you go to Help and Keyboard Shortcuts card and click on that. Here we see a lot of NetBeans keyboard shortcuts. So I strongly encourage you guys to go through this and find shortcuts that may be useful, and then we'll start using them. All right, so before modifying this class, we want to generate a new Java class or develop a new Java class. So we right-click on the package. We can say New, and then click on Java class. Name it Customer. Okay, let's add a few instance variables. So following Java conventions, variables should be private. Type PRI and then hit Control Space. NetBeans completes. It guesses that we want to type in the word private, and it completes. Our variable type is going to be of type string, so str Control Space. In this case, NetBeans is not sure what type we want, so it gives us a few options. Just pick the right one, and off we go. Okay, we just type in the variable name. Our second variable is going to be the same visibility, private, and the same type. So instead of typing all this again, we can duplicate this line. And to do that, we hit Control-Shift, down arrow, and then just change the name. Okay, and let's add a third variable, type int. Let's name it age. Now all of these variables are private, so to access them outside the class, we need accessor methods or getters and setters, which can be generated automatically. If we hit Alt-Insert, that's the code generation keyboard shortcut. Select getter and setter, then pick the variables that we want to generate these methods for. If we want all of them, we can just click on the class name and then click on Generate. There are our getters and setters. Now our code is not formatted exactly right. To format it, we can hit Shift-Alt-F, and that formats our code. Now, before moving on, we would like to add a convenience constructor to initialize the variables. So again, Alt-Insert for code generation, and then select constructor, and then pick the variables that we want to initialize. In our case, we want all three. So click on Generate, and again, format the code, Shift-Alt-F, and there's our constructor. Now, the Java Beans specification requires no argument constructor, so let's go ahead and generate one just to be compliant. Constructor, and then pick nothing, and there it is. Shift-Alt-F again, and we're done with this class for now. Now, going back to our main class, here we see some boilerplate comment that NetBeans add. We can delete this line or any line by hitting Control-E. And that deletes the line in one shot. Now let's create an instance of our customer class. CU, Control Space, NetBeans completes. Now if we just hit Control Space here, NetBeans will provide some suggestions for variable names. Personally, I like readable variable names, so I'll pick the customer spelled out variable name. Equals new, Control Space, Okay, so we want the constructor that initializes the variable, so we pick that, add a few values. John Doe 33. All right, and then let's just print out the value of this variable to the console. So system out print line completion customer. Now when we invoke this method, let's go ahead and run it. We can go up here, run project or run file, or we can hit F6 for the project or shift F6 for the file. In this case, it's equivalent because our project only has one class with a main method. Let's go ahead and click that, and here's the output. And what we see here, this is the output of this system out print line right here. As we can see, this is not really very useful. It's just kind of like an internal representation of the object. So to get some useful output out of that, we need to add a toString method in our customer class, and NetBeans can generate that. So again, Alt Insert, select toString, and select the variables that we want to display in the toString. By default, all three are selected, and that's what we want. So we just click Generate, and this is our toString method. As we can see, it will show the variable names and their values. Let's format the code, Shift Alt F, and then we can run the project by hitting F6. And here we see the output. Again, variable name and value, and this is much more useful. So that's it for this lesson. What we want to show here was keyboard shortcuts and code generation features that NetBeans provides that make our lives as a developer a lot easier. So I'll talk to you guys in the next lesson. Welcome. In this lesson, we are going to keep talking about the NetBeans editor. Specifically, we will be talking about code navigation. We will see how we can turn method calls into hyperlinks, and then click on that hyperlink to quickly navigate to a method call. We'll see how NetBeans has browser-like navigation. Just like in a browser, we can go back and forth in our browsing history. In NetBeans, we can go back and forth between sections of code or files that we've been looking at. And we'll see a very handy feature of the NetBeans IDE is the navigator window that allows us to quickly navigate to sections of code within a source file. So here we have the project that we developed in the last lesson. And here we have a call to a constructor in our customer class. So if we want to go to the source for this constructor and see what it does, instead of opening the customer.java class and scrolling up and down to find it, we can simply hit Control and then hover the mouse over the call and then click on it, and we're taken to its declaration. This also works for methods, not just constructors. So just add a method call real quick. And then hover and hit Control, and we're taken to the method declaration. Okay, and in addition to using Control click, we can use a keyboard shortcut. If we have the cursor over the method that we want to navigate to, we can hit Control B, and it has the same effect. It takes us to the method or constructor declaration. Okay, I mentioned during the intro that NetBeans has browser-like navigation. So once we're here, if we want to go back to where we were, we can hit Alt and left arrow, and it takes us back one step in the history. This is what the code that we were looking at before we went to see what first name looks like. And again, if we want to go forward, we can hit Alt and right arrow. Just like a browser, those are the exact same keyword shortcuts that all popular browsers use. Another nice feature we have this customer.java class, which is simple. It's not bad at all. But in real life, we will be working with long, convoluted, complex Java classes. And let's say that I know there's a method in this class somewhere called, I don't know, setAge. But I don't know where it is, and I don't want to be scrolling up and down, or if I use search, I'll hit a bunch of results that are not the method declaration. So in NetBeans, we can hit Control F12, and that takes us to the navigator window here in the bottom left. And this navigator window, we can start typing the method name. So what was the setAge? And as we type, it highlights whatever method starts with whatever we're typing here. So once it finds it, we can hit enter, and we're automatically taken to the method declaration. This also works for variables. So if I hit Control F12 and start typing first name, it's highlighted, so I can either click on it, double click on it, or hit enter, and we're taken to the variable declaration. So that's it for code navigation. This actually saves a lot of time. It's a few seconds here, a few seconds there, but it adds up. So, it is worth it to get familiar with these navigation tricks that NetBeans provide. Welcome back. In this section, we will be talking about refactoring. What is refactoring? It is changing the structure of the code without changing its functionality. And why would we want to do that? It's so that we can make our code more readable or make it conform to standards without introducing bugs, keeping the code functionality as it is. So NetBeans has a bunch of built-in refactoring capabilities. We're going to look at a few of them. We'll see how we can rename variables so we can make them more readable. We'll see how we can encapsulate fields. The Java convention is to have all instance variables private and have public getters and setters to access them from outside the class. So if we run into some code that does not conform to the standard, NetBeans has the capability to automatically change the code to conform to that standard. And we'll also see how we can extract a method from existing code. Okay, so here we have a very simple Java project. It has two classes. Class with a main method and essentially a value object. Now, if you guys notice this value object, let's start with the variable names. L1 and L2, they stand for line 1 and line 2. These names are not exactly readable or programmer friendly, so we would like to change them. But if we just go ahead and just change it like that, we're going to break the client code that's using that variable. So let's go ahead and put it back the way it was. And there is a refactoring for renaming a variable. We can either go up here, refactor, and then rename. Line 1. And now we change here, and it changed over here as well, so our code did not break. And there is a keyboard shortcut. We also want to change L2, Control R, and that brings up the refactoring pop-up window. So it's faster than going to the menu. L2 was not used in the client class, so that did not change. Okay, so now that we did our renaming, notice that all of these variables are public, and standard Java conventions require this to be private and have getters and setters. So we can right-click, select refactor, and select encapsulate fields. Okay, in our case, we want all of them, so we just say select all, click on refactor, and notice that all of them are private now, and they have getters and setters. And if we go to the client code, instead of setting the variables directly, the setters are called, and same thing for getting values. The last thing that I want to show is introducing a method. If we highlight some code, right click, refactor, and introduce method, let's call it init address. A new method is created, and we can see it's called right here. Okay, so there are a lot more refactoring capabilities in NetBeans. I encourage you guys to go through the list on the menu and experiment. A lot of them are fairly self-explanatory. Unfortunately, we don't have time to go through all of them. But you guys saw, gave you guys a taste of what is possible. So go ahead and go through these and explore. You'll be glad you did. So that's it for this lesson. I'll see you guys in the next lesson, which we'll cover NetBeans visual cues. Welcome back. In this section, we are going to talk about NetBeans visual cues. As we work with Java code, NetBeans will provide some clues as to what is going on with our code. Like, for example, if we have compilation errors, the lines that won't compile will be underlined with a red squiggly line. If we have unused variables, they will be underlined with a gray squiggly line. And if we have warnings, those will be underlined with a yellow squiggly line. Also, inheritance hierarchy clues, that means that if we're working with a class that extends another class or that is extended by another class, we can see which methods we are overriding from the parent and which methods are overridden in child class. So let's take a look. Here's a very simple Java project. As we can see, we have a red squiggly line here, and we also have a light bulb in the gutter. And the light bulb means that NetBeans has a suggestion on how to fix the problem. So if we hover over the line, the variable that's not compiling, we can see that we can hit Alt-Enter, and NetBeans will give us a hint on how to fix that. And in this particular case, we have 3 hints, and the actual problem is that we don't have a field named site2. So if we just click on this, it will be automatically created. So that problem is solved. Also, up here we have an import that is underlined with a yellow squiggly line. A yellow squiggly line is a warning. So again, hovering here, we'll see that this import is unused. So if we hit Alt-Enter, NetBeans offers to remove the use import. So we can just hit Enter, and it's gone. So that problem is solved as well. Finally, we have a variable here that is underlined with a gray squiggly line. And again, hovering over it, we'll see a tooltip that says that this field is not used. So we can delete it. The keyboard shortcut in NetBeans to delete a line is Control-E. So that is gone. All right, so no more warnings, no more error messages. But we see here, we see some little circles or symbol on the left-hand side gutter. So this gray circle with an O, that tells us that our class is being extended or has subclasses. We can hit Control-Alt-B to go to the subclasses, so we can click on that symbol and that will take us to the subclass. We see a green circle with an I. And what that is telling us is that this method is declared or defined in the interface that we're implementing. So again, we can hit Control-Shift-P if we're in the method, and NetBeans will take us there. Or we can simply click on the icon, and it has the same effect. Okay, so here we see another I, same thing, another method in the interface. This O, gray O, that means that the method has been overridden as well. So again, we can navigate by clicking on it or Control-Alt-B. Okay, so as we can see, NetBeans can provide some very nice clues to let us know what's going on with our code. That is especially useful if we're working on code that we're not familiar with. At a glance, we can see what is going on and somewhat, get some idea of the inheritance hierarchy, as well as providing warnings and compilation errors on the fly. So that's it for this lesson, and that is it for this section as well. In this section, we cover mainly NetBeans, refactoring, navigation, things like that. In the next section, we will actually start talking about Java EE, and the first topic that we will cover is JSF. So I'll see you guys then. Welcome back. In this new section, we are going to be talking about the NetBeans debugger. What a debugger does, it allows us to kind of figure out what's going on behind the scenes with our code when things aren't working exactly right. We can suspend execution, inspect variable values, and things of that nature. So in this particular lesson, we are going to be talking about breakpoints. There are several types of breakpoints. We're going to be talking about some of the most common, including line breakpoints, method breakpoints, and exception breakpoints. And we'll explain what they are as we go on. Here we have a very simple Java class. This is CS 101 kind of thing. Our objective here is to demonstrate debugging, not to show complex Java code. So this is a very simple class with a main method that initializes an array list with a string representation of the musical notes, and then displays those values on the console. So let's go ahead and run our code. Okay, and here we see the output. And notice that we never see the first element of the array. So something is not quite right. And like I said, this is very simple code, so some of you out there probably know what's going on already, but let's pretend we don't know what's going on. Our problem could be that maybe for some reason the first element is never added, or maybe it is added but it's never displayed. So let's go ahead and add a line breakpoint where we initialize the array. So to add a line breakpoint, all we need to do is click on the gutter. Okay, there we go. And notice that the line turned red and we see a red square. That lets us know that there is a line breakpoint on that line. Now to debug our code, we can go up here, debug and debug project, or simply hit Control F5. Let's go ahead and click. Okay, and notice that this line turned green. What this means is that execution is suspended right at this point. If we look down here, we see a variables window, and all the variables that are in scope are shown here. This is the actual class, and inside the class we have musical notes, which is declared up here as an instance variable. That's our list of string or array string. Right now it is null because we suspended just before running or executing that line of code. So if we want to go ahead and execute, we need to step over that line, and we can do that by clicking up here or hitting F8. Okay, so notice that now our array list is not 0 anymore. It has a size of 0. It has no elements. We are suspended on the next line. This next line has not executed yet. If we step over once more, now we do add one element. And notice the size is now 1, and we can see that the first element, element 0, is do. So now we know that this method or this element is actually being added, so our problem is not here. So we can stop debugging, or we can hit continue, and that will continue until the program ends. Let's just stop. Okay. So we know our problem is not there, so to remove the breakpoint, we just click the gutter again, and it's gone. We don't need that anymore. Now, the problem's gotta be in here somewhere where we print the list. We could set a line breakpoint just like we did before, but I want to show a different kind of breakpoint. Just like I mentioned during the intro, we can have method breakpoints. So to add a method breakpoint, we need to open the debugger or the breakpoints window. So we go to Window, Debugging, and Breakpoints. Down here's the window, so we right click on it. Actually, let's click inside the method. Now if we right click on it, say New Breakpoint, yep, we want a method breakpoint. See, these are the different types. By default, it knows that we want a method breakpoint, and we can stop on method entry, method exit, or both entry or exit. For our purposes, entry is fine. So now print list values, it defaults to wherever focus is. So that's why I clicked inside this method before adding the breakpoint. We just hit OK. And notice we now see a red triangle, and that lets us know that there is a method breakpoint at that point. Let's go ahead and debug our code again. Okay, so execution is suspended on the first executable line inside the method. Okay, so let's look at the output here. If we hit F8 or click up here, we go inside the loop, and let's actually look at the variables. Forget the output. Right off the bat, we notice this is the first time we go in. We see that the variable I in the variables window has a value of 1. But if we see musical notes, do has an index of 0. So there's our problem. We're never displaying the value or the element with index of 0. So let's stop debugging, change this to 0, and then run again. Let's just run. And our problem is fixed. So we're able to see that because we added breakpoints and debugged our application. Now, before moving on, we already fixed our problem, but I want to demonstrate one more type of breakpoint, which is the exception breakpoint. So I'm going to introduce an exception on purpose. If we run our code now, an exception will be thrown, index out of bounds. So let me copy that because I'm going to need it. Okay, so let's go back to the breakpoints window, right click, new breakpoint, and this time we want an exception breakpoint. Okay, and the exception class name is the actual exception that is thrown. So NetBeans default here is incorrect. Let's just paste. We want to suspend execution when an index out of bounds exception is thrown. So let's hit OK. All right, so here's our new breakpoint. And let's go ahead and debug our code. And an index out of bounds exception was thrown. This code that we see here, this is code from the Java development kit. This is not our code. So we have nothing to debug here, but if we look here, this is the call stack, and we can see what method called what other method. So this range check was called by ArrayList.get. It's not our code. That is also JDK code. And that was called by buggyClass.printlist values line 44, and that is our code. So now we know that an exception was thrown here. Now this particular example is very simple, but sometimes in production is, when we're dealing with very complex code, it might not be obvious when an exception is thrown. So this type of breakpoint is actually very useful sometimes. So that's it for breakpoints. In the next section, we'll talk a bit more about stepping into code and inspecting variable values. So I'll see you guys then. Welcome back. In this lesson, we are going to continue talking about the NetBeans debugger. Some of the topics that we're going to look into is stepping into methods. In the last lesson, we saw how to step over a method, but we didn't see how we can go inside the method body, so we'll see how to do that. We'll also be talking about inspecting variable values and expression values. There's a few ways we can inspect values of different expressions in the code when debugging, so we'll look at a few of them. Okay, so here we have our buggy class from the last lesson. I undid all the changes that we made in the previous lesson, so it's back to its original state. Let's go ahead and add a breakpoint here and debug our code. Execution is suspended at this point, and if we hit F8 or click on this icon, we step over that method and go to the next line. But what if we want, in this case, we're sitting here, and what if we want to navigate inside the print list values method? Well, what we can do is step into the method by clicking on this icon or hitting F7. So let's go ahead and click, and here we are. Okay, so that's how we step into a method. Now, the primary topic that I would like to cover in this lesson is inspecting variable values that we saw already. They're automatically placed here, but I want to add expression values. So notice this enter new watch here. If we click here, enter an expression, let's say musical note. By the way, control space works here for completion. Dot size, enter. Notice that we can see the value of this expression, so we don't necessarily have to have a variable defined so that we can see some values in the variables window. Additionally, typing all that is too much work. We can simply highlight an expression, and then the tooltip that comes up will let us know its value. So we don't even have to type that expression in the variables window. Okay, and one more thing we can do, let's actually hit F8 here so that we can move into the next line. Once we highlight an expression, just like we did, see, we can see the value. That's nothing new, but if we right click and click on new watch, by default, whatever expression is highlighted shows up on the window. We click OK, and here's a new watch. So there are several ways that we can use to add expressions to the variables window so that we can inspect their values, and this makes our debugging easier. That's it for this lesson. See you guys in the next video. Welcome to section 3, Java Server Faces. In this particular section, we're going to be talking about Facelets, which is the standard view technology for JSF or Java Server Faces. We'll be talking about managed beans and how they can be linked to faceless pages to hold data. We'll be talking about some JSF input and output tags, and we'll see some value binding expressions that are used to link the values in input fields to properties in managed beans. And then we'll see how we can handle form submissions. So let's create a project. Control-Shift-N. Okay, we want Java Web, and we do want a web application. Next, let's name it JSF Intro. We do want Glassfish as our application server. We want Java EE6 Web. We don't want CDI, context and dependency injection, so this all looks good. We do want JSF or Java Server Faces as our framework, and JSF 2.1 is the default. That's the one we want. Click on Finish, and our project is created. And right off the bat, this is a JSF page that is automatically created. Faceless pages are XHTML pages using XML namespaces. This H namespace here, or HTML, is used to render HTML to the browser. We haven't written a single line of code, but we can already run our project. So right click and run. Okay, and here is the page that was automatically generated when we created our project. This hello faceless right here is this hello from faceless over here. Okay, so this is a very simple page, but we already have a functional project. Normally what we would do is have forms for user input and then process that input and then show some kind of confirmation page. So before we can do that, we need to have what is called a JSF-managed Bean. JSF-managed Beans hold the information or the data the user enters into memory, into their properties. So let's go ahead and create a JSF-managed Bean. Other, Java Server Faces, and JSF-managed Bean. Let's call it customer because it will hold customer information. Let's put in the package. Okay. Managed beans have different scopes. These are the standard scopes that you have in most web applications. Request, session, application, or view. Request, the bean is created and or lives through a single HTTP request. Session, it lives through each user session. Application, we have one across sessions, or the same one is shared across user or sessions. View is only for a single page. In this particular case, request, which is the default, would work for us. Let's click Finish. And our managed bean is created. Notice this is a standard Java class. The only difference is this managed bean annotation marks the class as a JSF managed bean, and request scope marks it as the scope of request as we saw during the wizard. Okay, what we need to do is add a few properties that are going to hold the data entered by the user. So let's just add a few here. First name, then Control-Shift down arrow to copy the line. We want another one called last name. And then we want a third one. Let's make it integer. Integer object for H. Now these are private, so we need getters and setters. So Alt Insert Getter and Setter. Select all of them and click on Generate. And we have our JSF managed bean. Simple Java class, a Java bean, no argument constructor, a few properties with getters and setters. That's all there is to it. Back to our Facelets page, just like with standard HTML, we need to put our input fields inside a form. So in JSF, we use the hForm tag. Okay. Now we want to lay out our components in rows and columns, kind of like a table. So for that, we use the panel grid component, and it has a columns attribute which specifies the number of columns, and we don't need to specify the number of rows. So close that tag. Now we want a label. Output label is the name of the tag. This for attribute uses the ID of the input component that this label refers to. So it's going to be first name, and then values was going to be shown in the browser. So user-friendly first name. Okay, so this is our label. Now for the actual input field, input text, ID equals first name, and then value equals, and then the syntax here is for value binding expressions. Customer, this is our bean that we just wrote, dot first name property. So whatever value the user enters into this input field will be assigned to the first name variable in our managed bean. And notice that the value of the for attribute in the label matches the ID of the input field. Let's take a look at our page. We just made a few changes. All we need to do is reload. And here, this first name that we see here is this first name over here. That's the label. And this is the input field that we just added. Okay, so let's add a second input field. If we highlight these two lines and Control-Shift down, they get copied. So now we want last name. Control space, last name. Okay, and we just save and reload, and there's our second input field. Now lastly, we want age, a third one for age. So Control-Shift down. Okay, now let's take a look at the page again. 5 to reload, and there's our third input field. Now we need a submit button to submit the form. Now notice these components are in a grid, in a panel grid, and since we specified that there are 2 columns, after we add 2 components, the third one goes in the next row. We add 2 more that goes in the third row. So the next component that we add will be in a cell right here. So if we add the button here, it's not going to look nice. We want it to align with the input fields. So we can put an empty panel there just so that that cell stays empty. So for that, there's a panel group tag that we can use. And then the tag for the actual button is called command button. Value equals submit. And that's the label that's going to show on the browser. And then action, if we specify the name of a Facelets page here, automatically by convention, JSF will navigate to that page. Now we don't have a confirmation page yet, but we are going to write one. Now let's take a look at the page to see how we're doing. There's our submit button. We won't click it yet because we will get an error if we try to submit. Okay, so let's go ahead and create our confirmation page. We can do it here, JSF page, or we go to Other, Java Server Faces, JSF page. Okay, we want to name it Confirmation. Okay, and click on Finish. And let's just add some static text. And we can add an expression here. This will show the value of the first name property on the browser. And what I meant here was BR, not B. Another BR here. Last name. H. Okay, so we're ready to run. Let's reload. Say John Smith, 20 years old. We'll submit, and this is our confirmation page. And what we're seeing here are the values that we entered. They were automatically stored in the managed bean, and then we could display them on the confirmation page. So that's it for this intro to JSF. See you in the next lesson. Welcome. In this section, we're going to talk about Facelets templating. We'll see how we can create a new Facelets template in NetBeans. We'll see how we can preview the template in the browser. Then we'll see how to create a template client. And finally, we'll see Facelets templating in action. But before we do all that, let's explain the problem that templating solves. So here we have the pack publishing website, for example, and notice that there's some areas that are common across several pages. Like, for example, this header up here with login and password and search and whatnot, that is there on every page, or at least on several pages. Same thing with this menu here and all the items in this area here. So we don't really want to repeat the markup for those areas on every page over and over. And what if we need to make a change? Then we have to go and change every page. So what Facelets templating allows us to do is to define these common areas, or whatever common areas the page has, into a template, and then we write template clients that inherit from the template, and the common areas are just defined in one place, namely the template. So let's take a look. I already have a JSF project. It was created just like was explained on the previous version, so that will save us some time. To create a template, we right-click on Web Pages, say New, Other, Java Server Faces, and Facelets Template. Okay, we give it a name. I'm just going to say Template. And we can pick, NetBeans provides several predefined styles that we can use. So here, for example, we will have a header that every page inherits from. This one will have header and a footer. This looks like it will be for our menu, so on and so forth. So for our purposes, the header one will suffice. So let's just use that. Okay, let's click Finish. Okay, notice this UI insert tags here. These define the common areas that are defined on the template. The clients will have a corresponding tags that they can use to overwrite the content in the template, and if one of those tags is missing, they'll just use the content from the template. And we'll take a look at that when we develop the client. But right now, let's take a look, or let's look at the template in the browser to see what it looks like. So let's just right-click and run. Okay, and we want template.xhtml. So that's what it looks like. This top here, this is the header, and that's what we want in every client. And then the content will be different for each client. Okay, so let's go ahead and create a client. So on Web Pages, right-click on New, Other, Java Server Faces, and Facelets Template Client. Okay, we give it a name. I'm just going to name this one Client. Folder, the default is fine. We need to specify the template that we're going to use, because there could be multiple templates on a single project. Ours is called template.xhtml. Okay, generated root tag. In general, we want HTML, so this looks good. Let's click Finish. And here's our template client. Remember, I mentioned that the clients have tags that correspond. Here in the template, we have UI insert, and in the client, we have UI define. So if the client wants to overwrite the content on the template, it will use a UI define client, and whatever we put here will be placed on the render page in the area defined by UI insert. So in our case, we do want the top UI insert from the template, so let's just delete that. we'll just inherit the content from the template. And we do want specific content for the client, so let's just say client content. Let's keep it simple. Okay, so we can right click on our client and click on run file. And this is our client. So all we coded was the content, this text here, and this comes from the template, and all the layout and CSS and everything else comes from the template. So this was a very simple example, but it illustrates the problem that templating solves. We can define all these common areas on the template, and then in the clients we just need to specify the markup that is specific to the page that we're developing. So that's it for faceless templating. See you all in the next lesson. Welcome back. In this section, we are going to continue talking about Java Server's Faces. Specifically, we'll be talking about managed beans. Now, we talked a little bit about managed beans before, but we're going to go a little bit into more detail. The first thing that we're going to cover is managed properties. Managed properties allow us to access a managed bean from a different managed bean. We'll see how that works in detail. And also, so far, we've seen managed beans acting as the model in the model view controller design pattern. They can also act as controllers. That is, they control navigation from one page to another. And to do that, we need to add action methods, and we'll cover how to do that in this section as well. Okay, so here we have our customer managed bean from before, and there's a new managed bean here called address. So we want to make address a managed property. So to do that, we add a variable of type address. And let's add the getter and setter that can be generated. Insert, getter and setter, select address and click on generate. Let's format the code, Shift-Alt-F. Go back here, there's one more thing that we need to do. We need to add the managed property annotation and set its value attribute to an expression language expression that corresponds to the managed property, that the managed bean that we want to assign to this property. Now remember that if we don't specify a name for our managed beans, by default its name is the class name with its first letter switched to lowercase. So this expression here maps to our address managed bean. Okay, so now we have a managed property. So how do we access it from the markup, from the XHTML? It's actually pretty simple. Let's add a couple more fields to our input page. First, a label. Let's go to line 1. Oops, line 1. Address line 1. And now the actual input field. Text. Line 1, and then the value. And here we use a value binding expression. Customer the address dot line 1. So as we can see, we use the dot notation. From customer, we access the address managed property, and then we access the line 1 property of address. Let's add one more. And this is going to be line 2. and line 2. And I'm not gonna do the others because it's all the same. It's all very repetitive, so I don't want to bore you guys. But essentially, that is how we access manage properties from the HTML. Now let's change the confirmation page so that we actually see the changes to those managed properties. Let's add, it's the same expression, customer, the address, the line 1, and then customer, the address, and line 2. Okay, so let's go ahead and run our application. Okay, here we are. Notice address line 1 and address line 2. These are new. The rest is the same that we saw before. So let's just add. Doesn't really matter. 2. We click submit. And we navigate to our confirmation page. And here we see that the values have been stored in our managed property. So that's it for manage properties. It's actually fairly simple. The thing that we need to remember is to use this manage property annotation. Now the other topic that I want to cover in this section is using managed beans as controllers and adding action methods. So let's add a new JSF-managed beans. Other JSF Java server faces and JSF managed beans. Let's call it customer controller. The request is fine. Okay, so here we have the generated customer controller. Let's add an action method. Let's call it navigate. Okay, an action method has to be public, has to return a string, and must take no argument. The actual name of the method does not really matter. Usually, in these methods, we have some processing. So typically, saving to a database. So and it can return any strings, and we could have some logic here that depending on the logic, we can return one thing or another. But for this simple example, we're always going to return confirmation. And the string that it returns must match the name of the page that we want to show. So in this case, confirmation.xml. So if we return confirmation, after this method takes control and returns the confirmation string, the JSF container will look for a file called confirmation.xml and display that. And so that we can actually see or execute this method, we need to change the action for our command button. And we need to add a value binding expression here, customer controller dot navigate. And just so that you guys believe me, I'm just gonna add system out print line here. So let's go ahead and run our application again. Here it is. So let's just use same values, click submit, and we see the same behavior. So if we see down here the glassfish log, we see that the navigate method was invoked. So this navigation methods or action methods allow us to have some dynamic logic that if this happens, go to this page, or if some other condition is true, go to some other page, so on and so forth. So we don't always have to return to or have to navigate to the same page. It can be dynamic. So that's it for this lesson. I'll see you guys in the next lesson. Welcome back. In this section, we're going to be talking about context and dependency injection, or CDI. First, we'll give a brief introduction to CDI, and we'll see how we can enable CDI in a NetBeans project. Following that, we'll see how to develop CDI named beans, and finally, we'll see how CDI handles dependency injection. So what is CDI? CDI is a way provided by the Java EE specification to integrate different layers of our application. For example, traditionally, when not using CDI, we have JSF-managed Beans handling the front end, controllers, and data beans and whatnot. And then we have Enterprise Java Beans handling the business logic. Now, we haven't talked about Enterprise Java Beans yet, but we'll cover them later in the course. Now, when using CDI, we can actually use Enterprise Java Beans as controllers for our JSF pages. So we get all the benefits of EJBs, or Enterprise Java Beans, in the front end. Okay, so having said that, let's go ahead and create a new project. Control-Shift-N. We're gonna call it CDI. To enable CDI, we just need to check that box. Okay, click Next. We do want Java Server Faces. Click Finish, and we're done. Now, when using CDI, instead of using JSF-managed Beans, we can create CDI named Beans. So let's go ahead and create one. It's going to be very similar to what we've seen before, but we're going to keep it simple. We just want to show the CDI plumbing, if you will, as opposed to, writing very elaborate or complex code. So we just create a new Java class. Let's call it customer. Okay. So here's our customer class. We'll just add a couple of properties. Then the getters and setters. And that's our class. Now, so far this is a standard Java class. To make it a CDI name bean, we use the named annotation. If NetBeans completion works, there we go. Okay, now this is a CDI name bean. We have to give it a scope. Pretty much all the standard scopes from JSF work here as well. We can make this one request scope. Yep, that's the one we want. So this is a CDI name bean now. We just add this couple of annotations and off we go. So let's go ahead and modify the generated index.xhtml. Add a form, a panel grid, 2 columns, for equal first name. Okay, and then let's add an input text just like we saw previously. And here we can use the expression language just like before and we get completion. First name. Okay, now let's just duplicate these 2 lines and make the necessary changes. I think we're good. Okay, now we need to add a submit button. So for layout purposes, now group, command button, confirmation. So now let's add a confirmation page. Okay, and again, just like before, we're just gonna add a couple of scripts, expressions from the expression language. Let's add some static text so we know what we're looking at. All right, and that should do it. Let's go ahead and run our application. Okay, here's our browser. See, and it works just like before. So, the benefits might not be obvious right now, since it's behaving just like a standard JSF application. However, like I mentioned, one of the big things is that we can use session beans or enterprise Java beans as managed beans or controllers. And another nice thing is, even though dependency injection is already fairly simple with managed beans, CDI makes it even simpler. So let's go ahead and take a look at that. Again, let's create another Java class, and again, very similar to what we've seen before. Let's name it address. Okay, and then to save time, we're only going to add a couple of properties again. Line 1, line 2, and let's add the getters and setters. Okay, and to make this a CDI name bean, again, we need the name annotation. Named. And then we need another annotation for the scope. Quest scope. All right, now back to our customer bean. Let's add a property. And there is a slight bug in NetBeans 7.3. It gives us this error message that says there is no beans.xml file when there is. We can just ignore that for now. It works fine. Now let's go ahead and add address, and then the getters and setters. Alt insert, getter and setter for address. Generate. Now, to get this injected at runtime by the application server, all we need to do is use the inject annotation. We don't have to instantiate it. We don't have to invoke the getters or the setters. The application server will inject an instance automatically. Okay, so let's go ahead and make a couple of changes to our pages, just so that you guys see that this works as intended. Let's just add another output text. Actually, let's just copy copy these two guys to save some time. Line 1, let's just say address line 1. All right, and then again, line 2, 2. And now the confirmation page. Actually, let's add the BR here. Change the label. Two. We can remove that BR. Okay, let's go ahead and run our application. Just deploying. A new tab is going to show up here soon. Here we go. So 1, 2, 3. I don't know, line 2. Submit. And we see everything here. So we see that the properties got populated the way we intended. So what we've seen here is CDI simplifies dependency injection. And what we haven't seen, because we haven't covered EJBs yet, or Enterprise Java Beans, is that it allows us to have EJBs as JSF-managed Beans, which is something that a lot of people really wanted for a long time, and finally, with the introduction of CDI in Java EE 6, is finally possible. So that's it for this lesson. I'll see you guys in the next lesson. Welcome. In this section, we're going to continue our discussion of JSF. Specifically, we'll be talking about JSF validation. These are the topics that we will be discussing. We'll talk about how to display validation message. We'll also see how we can do type validation. For example, if a field expects a number and the user enters a letter, how do we handle that? We'll also talk about how to make fields required and how to validate the length, how we can specify minimum and maximum length for an input field. And also, for numeric values, we can validate a range of values. The minimum value is acceptable and the maximum value. So here we have a project that we've been working on for the past few lessons. It is the same project. We're going to add some validation to it. The first thing that I want to show is how to display validation message. The most common way is to use the H messages JSF component. Then validation message will be shown wherever this tag is, in this case at the top of the page. Okay, so I mentioned that we want to do type validation. For example, in this page, in this markup, we have field age that is of type integer. So what if the user enters a value? A letter there. Well, turns out we don't really have to do anything. JSF takes care of that validation for us automatically. So let's go ahead and run our application. Okay, here it is. And let's enter a letter here and hit submit. And this is the age messages component in action. Age must be a number. So we enter a letter. Let's just enter a number. 10 will do. And that works. This is our confirmation page. We didn't enter anything on any other field, so we just see the age. So type validation is a given by JSF. We as application developers don't have to do anything. Okay, so what if we want to make some fields required? For example, we don't want to allow the user to leave the first name or last name blank. That there is a required attribute. For input fields, we just set it to true, and our field is required now. Let's do it for last name as well. Okay, now let's reload our application. Okay, now require validation kicked in immediately because the applications submit our request automatically. If we hit submit, see, we're getting validation errors for first name and last name. So let's add a name. Actually, let's just add a name for now. No last name. See, that validation passed, but our last name is still required. Now we submit. Validation passed. Okay, so that's all we need, the required attribute for required validation. Length validation. Let's say that we don't want to accept a name that is longer than, let's say, 10 characters. For that, we need to use a nested f validate length tag or component, and it has both maximum and minimum attributes which specify the minimum or maximum allowed values. We can specify one or the other, or we can specify both. In this particular case, let's just specify the maximum, let's say 10 characters. Okay, so f validate length. Going back to the browser, let's reload our page. Okay, so this is a long name. Submit. So length is greater than the allowable value of 10. So that's our length validation in action. Okay, change it back to James and submit. And now validation passed. Okay, and the last thing that I want to show is range validation. That is for numeric values. It works for longs or integers or floats or what have you. We happen to have an input that is numeric here, age. So let's add a range validation. Okay, so whoops, validate. Okay. Validate long range will work for integers. And again, we can specify a minimum and a maximum. Let's do both. We don't want negative ages, so the minimum will be 0 for a baby. That's less than a year old. And maximum, let's say 100. Some people live past 100, but it's very rare. Okay, so now if we go back to the browser, yeah, let's reload this, F5. Okay, so let's enter at age of -3, for example. Age is not between 0 and 100. Specify an age of 200. Again, we see the validation error. Let's change it to 50. And now validation passed. So as we can see, it's very simple to add validation using the JSF built-in validators. We can use long range or double range for numeric values. We can use the require attribute to make something required. We can use the length validator to specify minimum and maximum lengths. And for types, numerics for example, we don't have to do anything. JSF takes care of it for us. So that's it for this lesson. We'll see you guys in the next lesson. Welcome back. In this video, we're going to keep talking about Java Server Faces. Specifically, we're going to be talking about composite components. Okay, so first we're going to give a brief introduction of what composite components are and how can they help us. Then we'll cover the NetBeans wizard to create composite components. This is what I like to call the easy way of creating composite components. And then we'll see how we can reuse existing markup, refactor existing markup, and create a composite component from it. And this is what I call the super easy way of creating a composite component. Okay, so here we have the project that we've been working with. I did add a few more lines for address input that you guys didn't see in the video. It's pretty much the same thing that we've seen before. Actually, let's go ahead and make a copy of index.xhtml because I want to leave the original intact for now. Okay, default name is fine for now. Before we start making changes, I would like to explain about composite components. What they are just pieces of markup that we reuse across the application. Like, for example, if we need to enter several addresses on one page, or if we need to enter addresses in different pages, we don't want to be copying and pasting that markup for address information over and over. So we can create a composite component that accepts address information and renders all the input fields. And then we can just use our composite component wherever we need address input. So it is a way to avoid copying and pasting and having to repeat ourselves over and over. Okay, so having said that, let's go ahead and create a composite component. So we right click on the project, new, other, Java Server Faces, JSF composite component. And we're going to call it address. Click finish. And this is our composite component. It has two sections, interface, and this is where we declare any attributes for the composite component, and implementation, which is where we put the markup that will be rendered on the page. Now, like I mentioned, what we're going to create here is an address composite component. So let's go ahead and copy all of those address components, input fields, paste them here. Okay, we need to add a panel group here, a panel grid, so that they align properly. Okay, Alt F. All right, so let's go back to index1.xhtml. Let's get rid of that. We don't need this panel group anymore, and let's move the command button out of the panel grid as well. Now let's go ahead and add our address composite component and run our application. So what we want is index1.xhtml. Now here is our component in action. All this markup here was rendered from the composite component. Now let's go ahead and add an attribute. For that, we use cc.attribute, give it a name, address type. We want that to be a string, so we need to specify that. And then we want this to be required. So we can set required to true. Okay, and in the implementation section, we can add an h3 HTML tag and add an expression here using the expression language. The cc.attribute.an address type. That's this address type here. So NetBeans completion is smart enough to use our own attributes. If we pass home as the address type, this will render home address. If we pass work, it will render home address, so on and so forth. Go back here. Now, there's a problem here because we added a require attribute. So let's just go ahead and add the attribute here. And if we go back to the browser and reload our page, there's our header. And this is the value that we passed, home. And this is being rendered from this expression here. Okay, so if we needed to add 2 address input fields into this page, we could just, again, address type, let's say work this time. And if we go back to the browser and reload, now we have a home address and a work address, and these were rendered using our composite component. Now, like I mentioned during the intro, what I show here is the easy way of creating composite component. There's an even easier way. Sometimes we don't realize that we need a custom or composite component until after we've developed a page. Let's say we already developed this page and we figure, hey, I'm gonna need this markup over and over in several pages or whatever. So we can't take some markup on the page. Like, let's grab this panel grid. Actually, let's move the command button. Let's get rid of the panel group and move the command button out of the panel grid. That one I don't want repeated. Okay, so if we grab this panel grid, we highlight it, and we say refactor and convert to composite component. In this case, we have user information like name, first name, last name, age, and we also have address information. So let's just call it user info. Click finish. Okay, here's our user info that was generated. Essentially, I just took all the markup that was on the page and put it here. And if we go back to index.html, the markup disappeared and it's replaced by our new tag. So if we go ahead to the browser and render index, there we go. The page looks exactly the same as before, but the implementation is different. We refactored all the markup here and created a custom component, a composite component from it. That's it for composite components. As you guys can see, it's very easy to do it with NetBeans. It's no big deal. So I'll see you guys in the next lesson. Welcome back. This is our last section on JSF. In this section, or this lesson, we're going to talk about PrimeFaces. Before we actually talk about PrimeFaces, we're going to give a brief introduction to JSF component libraries. Then we'll see how we can use PrimeFaces in a NetBeans JSF project. And we'll discuss a little bit about PrimeFaces components. So before delving into actually talking about PrimeFaces, let's explain a little bit what PrimeFaces is. PrimeFaces is a JSF component library. When working with JSF in the real world, very rarely do we use the standard JSF components that are included out of the box with JSF. In most cases, we are going to use a component library. There are several. PrimeFaces is one of the most popular ones, as well as the one that's best supported by NetBeans, so that's why we're discussing that one. A few other popular ones include rich faces and ice faces. The benefit of using a component library is that we can develop very professional looking applications with very little effort. Our application will look like, we had a web designer, and most of us are server-side developers that are not very artistic. But when using a component library, that doesn't really matter. So with that said, let's create a new project. We want a web application, so that is correct. Let's call it PrimeFaces Intro. All those defaults are fine. we want Java Server Faces, and here under the Components tab, we want to pick PrimeFaces. Remember I mentioned PrimeFaces is the best supporter of the bunch. If we wanted to use icefaces, for example, NetBeans does not include the icefaces library, so we will have to download them separately. Same for rich faces. But PrimeFaces is included, so we can just use it. Okay, let's click Finish. And our project is created. And we haven't done anything other than create the project, but we can run our application immediately. And here is what the index page looks like. And if we navigate to the welcome page, this page is created automatically by NetBeans using PrimeFaces components. So we can see it looks a lot nicer than the ones that we've been doing so far that use standard JSF components. So we can use this generated page as a template for our own PrimeFaces pages. So let's go ahead. This welcome PrimeFaces page is the one that's generated, and these layout units are the different sections. We have layout and layout unit, and this is what we see here. This is one layout unit, this is another, and this is another, the footer here. So let's just add a few components to the main or the center layout unit. Let's make things a little easier on ourselves. Let's open a previous project. JSF validation will do. And let's grab some of the markup from the index page. Let's grab this whole thing, the panel grid, and all of its components. And let's put them here. And PrimeFaces includes replacements for all standard JSF components. So for example, PrimeFaces has a panel grid component, input text, so on and so forth. So we can highlight this and then Control H for replace. Yes, and then everywhere we see H column, we want to replace with P column. Replace all. Okay, notice the panel group now has a red squiggly line, meaning that there's an error there. The reason is that PrimeFaces does not have a panel group component, so let's leave the standard one there. Okay, so now we don't need to redeploy or anything. We can just reload the page, and this is our user info rendered using PrimeFaces component. Notice that the required fields have asterisks by default, so that indicates to the user that these two fields are required, and also all the components render so much nicer than before, the button and everything. So PrimeFaces has a lot more, many unique components. Unfortunately, we don't have time to cover it all. If we click on the demo here on the generated page, we can see all of the PrimeFaces components. So feel free to go and experiment in the PrimeFaces page and see what's out there. But for now, what we can see is that PrimeFaces has replacements for the custom components, and they render much nicer, so no reason to use the standard ones if we don't need to. This is it for JSF. See you in the next lesson. Welcome back. In the last section, we gave a brief introduction to PrimeFaces components. We primarily covered PrimeFaces replacements for standard JSF components. But that's not all there is to PrimeFaces. There are lots of additional components that are not available in standard JSF, so we'll take a look at a few of them in this section. First, we're going to take a look at the layout component that makes it easy to lay out our page with a header, a footer, main area, left-hand side menu, that kind of thing. It is typical to put an asterisk to indicate a required field next to the label. PrimeFaces can do that automatically, and we'll see how to do that here. The growl component is a very nice looking component that we can use to display messages to the user, typically used to display validation errors. Every JSF component library has a calendar component, and PrimeFaces is no exception. We'll take a look at it here. The spinner component makes it easy to input numeric values. And input mask is for showing or accepting input in a specific format. The example that we're going to look at is phone numbers, like parentheses for the area code and then a dash between the digits, that kind of thing. It can also be used for anything that requires a specific format, such as zip codes or anything else that you might imagine. Okay, so I actually already wrote some markup for this section. I started with the NetBeans generated XHTML page or facelet, and right off the bat it offers the layout component, and here we see the header. In a real application we would use a nice header here with images and what have you. We have on the right hand side we have a menu and a footer and the main area, and that is achieved with the layout component. So here we see p layout, we set full page equals to true so that it covers the whole page. And then nested inside it, we have layout units. The position attribute determines where that layout unit will be rendered. So north is for the header, south is for the footer, west is for the left-hand side menu, and center is the main area. Now there's also an east in case we need a right-hand side menu, but it's not being used here. Okay, so back to our page. Here we see an asterisk next to the label for this input field that is indicating a required field. Now I didn't add any markup for the asterisk to show. When using PrimeFaces, if we have an input field with its required attribute set to true, the label for that input field automatically will get that asterisk. Okay, so what happens if I submit without entering that data? We see this nice error message here. So that is generated by the growl component, which we have right here. Okay, so that is much nicer than the standard H messages from JSF. Okay, the next thing that I would like to cover is the calendar component. Here it is. Here we can see it in action. We can enter any date, future, past, what have you. We click on the number, and there we go. It's fairly easy to use. We just use pCalendar, and by default, this button here doesn't show, but the calendar pops up when we click on the input field. So if we want the button to show, we use the shown attribute with a value of button. Next is the spinner component. It allows us to enter numeric values just by pointing and clicking. Again, it's very simple to use. P spinner, and that's all we need to do. Has some additional attributes. You can look at the documentation if you need more information. And the last component that I would like to show is the input mask component. In this example, we want to enter a phone number, so as soon as we click, we see the format for the phone number. So, I don't know, 222-234-1234. So it's very nice, very professional looking, very user-friendly, and there's not much that we have to do. Just use the input mask component and then give a value to its mask attribute. So in here, the 9s represent any numeric value. So this will not accept any alphabetical values, only numbers. If we needed alphabetical values, we will use an A, and then that will only accept alphabetical values. For alphanumeric values, we will use an asterisk. Okay, but in this example, we're only taking numeric values. use. So that is all the time that we have. And again, this is very brief. There's a lot more to PrimeFaces. Just go to this URL and you'll see demos or a showcase of all of the PrimeFaces component. Okay, so that's it. See you guys in the next lesson. Welcome back. In this section, we're going to talk about the Java Persistence API. We'll give a brief introduction to JPA, what it is and what can it do for us. We'll see how we can generate JPA entities, and we'll also see how we can generate data access objects. Okay, so JPA, what it is. It is an object relational mapping tool. It essentially allows us to create Java classes that map to database table. So when we retrieve data, for example, from a table, our corresponding properties in the class will be populated with the data in the corresponding column. So here we have a brand new project using PrimeFaces. This is just a project that I just created. No code has been written yet. So I'll generate it. So let's go ahead and generate. If we right click, say new, other, persistence, and entity classes from database. Okay, we will be using the sample database that comes with NetBeans for our example, but you can connect NetBeans to any database that supports JDBC, which nowadays is pretty much any database. These are the tables in the sample database. We could add them, we could pick the ones we want, or we could just add all, which is what we're going to do for this example. Okay, we need to enter a package here. All right, and this defaults look fine, so let's just click on finish. And here are all of our entities. Okay, so let's take a look at one of them, a customer entity. First thing we see here is a bunch of JPQL, or Java Persistence Query Language. It is a query language similar to SQL, but to be used with JPA entities as opposed to with database tables directly. We'll talk a little bit more about JPQL later. And this JPQL queries are assigned to named queries so that we can reuse them easily. And again, we'll cover that later in more detail. And what we see here are a bunch of attributes. Notice that all of them has this column annotation, which means that these attributes are mapped to a column in a database table. So let's take a quick look. Here's the customer table in the database, and these are all the columns. So notice there's a customer ID. This is the primary key. And here's our customer ID attribute, and the column annotation, the name attribute matches the name of the column. Same thing for all of the attributes here. So now that we have our entities, let's go ahead and generate some DAOs, so data access objects. So new, other, persistence, and session bean for entity classes. Our DAOs are going to be implemented as session beans, which is a type of enterprise Java bean, and we'll cover them. We cover EJBs in more detail later, but for now we'll focus on the DAO functionality or data access object. Okay, so we can again pick one or more entity classes, or again we can say add all. Click next. Let's change the package. Let's say DAO. We don't need interfaces for this example, so let's just click finish. Okay, so here are our DAOs. Let's take a look at the customer facade, which is our DAO. Notice that there's not much code here. All of the generated DAOs or facades extend a parent class called abstract facade. So if we control click on that, we can navigate there, and all of the methods to insert or modify or remove data from the database or read or whatever, they're implemented here. So all the DAOs or all the facades just extend this abstract class. That way these methods don't have to be re-implemented over and over. So that's it for now. In the next lesson, we'll see how to actually use all of this code that was generated. So see you guys in the next lesson. Welcome back. In this lesson, we are going to continue with our introduction to the Java Persistence API, or JPA. In the last lesson, we saw how to generate JPA entities and DAOs. So in this lesson, we are going to see how we can use the generated code. So what we're going to do is we're going to write a JSF-managed bean that will act as a DAO client. Then we will update the markup to display data that was pulled from the database from the DAO. And finally, we'll test the updated application to make sure that everything is working as expected. Okay, so here is our application from the last lesson. I haven't made any changes to it. We have a number of facades or DAOs here, so we want to be able to use this code and interact with the front end. So it's always a good practice to separate the layers of our application. So let's write a managed bean that will act as a controller in the MVC design pattern or model view controller. So new, other, Java server faces, and JSF-managed bean. Let's name it customer controller, and we will put it in a package called managed bean. Click finish. Okay, here's our managed bean. The first thing that we need to do is inject the DAO that we're going to use. The DAO is implemented as an enterprise Java bean, an EJB, so we can use dependency injection. Okay, here's the declaration, and we can inject it by using the EJB annotation. So automatically, we don't have to instantiate it or anything. Automatically, it will be injected at runtime by the application server. Then we're going to need a list of customers that is going to be displayed on the front end. So let's go ahead and write that. Customer. Okay, and this is, we're missing an import. So there we go. And this is a private variable, so we need public getters and setters. We can generate them with alt insert, getter and setter. We just want the customer list. Okay, so now we have our getters and setters. Now, to actually populate this, we need to invoke a method on the DAO. The method is called findAll. We can, when working with managed beans, have a method that is invoked automatically when the bean is instantiated. All we need to do to accomplish that is use the post-construct annotation. The method must be public and void. And in here, we can say customer list equals customer facade dot find all. Okay, so when this bean is initiated, this method will be called automatically. We don't have to invoke it ourselves. Then our customer list will be populated so that when the front end invokes the getter, there will be data to be displayed. Okay, so this is our controller. We're done with it. Now we need to make some modifications to the generated XHTML page or faceless page. This is the one that I showed you when we were discussing PrimeFaces. I haven't done anything to it, but let's just add a data table. PrimeFaces comes with its own data table component. So let's use that. It looks much nicer than the standard. The value should be some kind of collection. So in this case, it's going to be customer controller dot customer list, and then we need a variable var so that we can refer to each element as we loop through them. Okay, we're going to add a single column. Here we can add an expression. So cust.name. So this will show the name for each customer. The data table will loop through the list and will display each customer name on the page. So that's all we have to do. Let's go ahead and run our application. Okay, here is the application. Let's go to the welcome page. And this is the output of the data table showing all the customer names. If we look at the database, the sample database that comes with NetBeans, run that query, we can see that the values match what we see on the page. Okay, so that's it for this lesson. See you guys in the next lesson. Welcome. In this section, we are going to continue talking about JPA, or the Java Persistence API. Specifically, we are going to talk about entity relationships. Okay, we'll talk about database referential integrity in general. Then we'll explain what entity relationships are, and we'll see the annotations that allow us to create entity relationships. Okay, so let's take a look at the sample database that comes with NetBeans. This is a diagram with all the tables in it. Notice these lines joining tables. Those lines are for referential integrity or foreign keys. Like for example, a customer can have one or more purchase orders, and a purchase order can have only one customer. So there is a foreign key column that is pointing to the customer table, to the primary key. So if we try to delete a row from the customer table and there is any row in purchase order that has that primary key that we're trying to delete, the database will stop us. We won't be able to delete it. So that's what is called referential integrity. Also, this creates what is called a one-to-many relationship. I briefly touched upon that. One customer and many purchase orders. Now, the challenge that we need to address is how to map this in the JPA entities, the Java code. Now, fortunately, JPA comes with some annotations that allow us to create these kinds of relationships in our code. Remember from our previous lesson that we had all the JPA entities for these tables generated, and NetBeans is smart enough to notice these relationships and it adds the annotations automatically for us. Like we were just talking that the customer table or the customer class that maps to it has many purchase orders. For example, let's search for, there we go. Here we have the one-to-many annotation, and it's a collection because there could be many purchase orders. Cascade type equals to all means that all operations done on this class will go and be done on the other side of the relationship, the purchase order class. This map by customer ID is the name of the property on the other side of the relationship. So let's take a look at purchase order. Order ID somewhere around here. Maybe not. Oh, it was customer ID. Here is the other side of the relationship. As we can see, we have the many-to-one annotation, and we have a variable of type customer, which is the one side of the relationship. So this is how we map these one-to-many and many-to-one relationships in JPA. There's also a one-to-one annotation, but that is very rare to see that in a database because it breaks normalization, but it does exist, so I'm pointing it out just so you guys know that it exists. And there is a many-to-many annotation as well. In a database, when we have a many-to-many relationship, we need to have a join table. The sample database does not have any many-to-many relationships, so none got generated for our example. But if you guys want to learn more about it, there's information out there online, or you can purchase my Java EE with NetBeans book, and that is explained there. So that's it for entity relationships. In the next lesson, we'll see how we can generate a whole application from JPA entities, a whole web application using JSF, and we'll see how we can actually update the database using JPA code. So I'll see you then. Welcome back. In this section, we are going to continue talking about the Java Persistence API, or JPA. Specifically, we're going to talk about generating JSF code from JPA entities. NetBeans provide that functionality, and it's very useful, allows us to create applications very fast. So once we generate our code, we'll go ahead and examine the generated code that inserts data into the database. Same with the code that reads data, and also with update and delete code. So once we've seen what the wizard does behind the scenes, we'll go ahead and test the generated application. Okay, so here we have a JSF project. All I've done so far was generate the JPA code from the existing sample database, just like before, so nothing new yet. Now to actually generate JSF code, we right-click on New, Java Server Faces, and JSF Pages from Entity Classes. Now, even though the label here says JSF Pages, I would like to note that not only a markup is generated, but also actual Java code, JSF controllers, DAOs, and utility classes. Okay, click Next, and select all of the JPA entities. We could select one or two, but all will do. Okay, so let's set an appropriate package. DAO for the session means, and let's say JSF. For the controllers, all other defaults are fine, so we click Finish. Okay, the code is being generated. Okay, so here we have the DAOs, and they are exactly the same as we saw before, so we won't go into those. So they're just automatically generated in one step from the entities. And then there's also some JSF code that is generated, and that's what we see here. We have a number of controllers, also some utility classes, and there's markup. For each entity, there's a folder created, and each one has a create edit list. and view. Let's actually take a quick look at the application before examining the code. So right click and run. It's coming up. Okay. So that's what it looks like. This is the index page, and we have essentially menu items for each entity. So if we click on show all customer items, here we see a list, a table with them, and there's view, edit, and destroy links for each one of them. Okay, so there's a customer. We could edit it, or we could delete it by clicking on destroy, or we could create a new one. Okay, but for now, we're not going to do that. Let's examine the code first. Okay, so the controllers, here we have customer controller. Okay, there is a method to create. Okay, so it just creates a new customer object. Okay, there is a method to read. So it's called actually prepare view, so that actually gets customer object from the list that populates the table and uses it to populate the view page. For update, okay, here's our update method, and it invokes get facade, which gets us one of our DAOs or facades, and then invokes the edit method on that facade. As we can see here, just invokes the merge method from Entity Manager. Let's remember that Entity Manager is a class provided by JSF that has all of the database operations. And then the merge method grabs the data that is in memory and uses that to update the database. Okay, so let's go back to our controller. And then for delete, actual method name is destroy. So if we see this method here, destroy, and then that invokes perform destroy, which again calls the facade, and that calls the remove method on the facade, which as we can see here, in turn calls remove on the entity manager, and that actually deletes the data in the database. Okay, so those are the most important methods that show all the CRUD operations: create, read, update, and delete. So let's go ahead and test the generated application. We have it here. Let's create a new customer. Okay, let's give it an ID of 800. Test customer. Line 1. To city, state. Boog's phone number. Okay. Let's give it a $10,000 limit. Okay, there is a zip code database, and what we see here is the output of the toString method of the zip entity, which is not exactly user-friendly. We will have to change that to make it look nicer, but it is functional. Let's go ahead and pick a zip code, and then same thing for the discount code. This is the output of the toString method. So if we want to make that more user-friendly, we will have to change that toString so that it displays a user-friendly value. Okay, so if we click save, size must be between 0 and 2. Okay, so I guess we have a validation error. It's the state. So let's just use st. Save. Now we create our customer. So if we click on show all customer items, Okay, click on next 10. There's our test customer here. If we click view, we can see the data, just what we entered. Let's edit and let's change something here. I don't know, the phone number. Let's just change the last digit and save. Okay, so if we go back to show all customer items, here we see the updated phone number. Same if we click on view. Okay, and if we want to delete it, we can click destroy here. And the customer was successfully deleted and we don't see it in the list anymore. So as we can see, NetBeans can quickly generate a whole application for us. And granted, it's a little rough around the edges. Some of the strings are not exactly user-friendly, but with some minor changes, we can get a pretty good application that's pretty much 90% generated by NetBeans with writing very little code, if any code. We actually didn't write any code. We do have to make some modifications for these labels here and what have you, but for the most part, it's all generated. And while we were at it, we saw all the CRUD operations that are provided by JPA with Entity Manager. So that's it for this section. Next, we will discuss JPQL, the JPA query language. And well, I guess I'll see you guys in the next lesson. Welcome back. In this section, we are going to keep talking about the Java Persistence API, or JPA, specifically the Java Persistence Query Language. Java Persistence Query Language, or JPQL, it is a query language similar to SQL, but instead of dealing with database tables directly, it deals with JPA entities. So when we select or insert or update or whatever, we just use entities or Java objects in our queries as opposed to tables. In this section, we are going to give a brief introduction to JPQL. Then we'll see how we can select data with JPQL. And then we'll see how we can filter data using JPQL's where clause. Like I already mentioned, JPQL is a query language that we can use to retrieve data or insert or update or delete data from the database. And it is similar, the syntax is similar to SQL. And here we have a JPQL query. Select C from customer C. C is an alias. Customer is our JPA entity. And well, see, this is the alias again. We could select individual fields. For example, we could say c.id or c.name or what have you. But in this particular case, we're going to keep it simple and simply select the whole object. Okay, so JPA provides the query class, and we obtain an instance from it by invoking the create query method on our entity manager, and then we pass the JPQL query as a parameter to create query. So the query object in turn has a get result list that will give us a list of objects or JPA entities, in this case customer, that contains all of the results from the query. Okay, notice this method, this code, is something that I wrote by hand. It's not generated. I wrote it in the facade or DAO. So we also have a managed bean. And in the managed bean, I'm invoking this method, get all customers JPQL. Okay, so this is a public attribute of the managed bean. Therefore, we can access it from our page or our XHTML markup. And we can see that here we have a data table, and its value is the all customers property of our customer controller, which is our managed bean. And as we saw, this invokes the DAO, which in turn runs the JPQL query. So when this code runs, when this page displays, we will see the data that comes from the database. As we can see here, we have expression language expressions, and we'll see the ID, the name, and the phone of each customer. Let's run that file and see this in action. Okay, here's the browser, here's the page, and this is the ID, the name of each customer, and the phone number. It's not the fanciest or the prettiest looking page, but it does the job and it demonstrates what we're trying to do here, which is pull some data from the database. Okay, now this query that we see here just pulls all the customers, but what if we want, only one or a few customers? Well, we can use a where clause. See that name equals, and let's pick one from the browser. Jumbo Eagle Corp is fine. Okay. Redeploy. Actually, let's run the application. So I guess redeploy it. Let's go to the correct URL. It's customer list. And now we only see Jumbo Eagle Corp because it's the only one that matches the where clause. Of course, in real applications, we would take user input. From the user input and manipulate the output. So we have a quick example here on how to do that. There's a customer ID input page that asks for a customer ID, and then a submit button invokes the retrieve customer method on the managed bean, which in turn calls this get customer, which calls get customer JPQL, and again this has a where clause. And what we see here, this is a name parameter. We don't know in advance what the value of this ID will be. So this is passed from the input that the user entered. So again, we see create query just like before, but here we see set parameter, and then we use the parameter name. Notice that here it is prefixed by a column, but not here. And then the value of the parameter is passed here. So now this ID will be equal to whatever the user entered. Then another thing we see, since IDs are unique, in this case we're calling get single result, which will return a single object as opposed to a list like we had before. So let's go ahead and see this in action. Okay, here's our input page. Let's look for a customer with an ID of 2. Submit. And there's the data. So as we can see, the things that we saw here were just running a select query and returns all the objects in the database or all the rows in the database. Then we saw how to use a where clause to limit the number of rows that are returned. And then finally, we saw how to use parameters so that we can use user input and essentially build a query dynamically. So that's it for selecting data. In the next few lessons, we'll see how we can insert, update, and delete data. See you guys later. Welcome back. Last time we saw how to select data with the Java Persistence Query Language. In this section, we're going to see how to insert data with JPA. And I'm talking JPA in general because JPQL does not have an insert statement. We need to use the JPA Java API to insert data into the database. However, if we need to do bulk updates, we can do that with JPQL, so we'll see an example in this section. So continuing the application that we started developing in the last lesson, I added a very simple page. We can see the markup here. It's a page that has two buttons. One of them will insert rows into the customer database, and the other one will update. Now the user interface is very simple because this lesson is about JPA, so we are going to focus on the JPA and JPQL code as opposed to the JSF markup. In any case, after deploying, this is what the page looks like. Just two buttons. When we click this one, some rows are inserted into the customer table, and this one updates those rows. But we're not going to click those yet. First, I want to go through the code to insert. So as we can see here, this command button, its action is a method called insert temporary customers on a managed bean called customer controllers. So if we control click there, we can immediately navigate to that method. So as we can see, this method in turn calls another method on the facade or DAO. We don't want to do database manipulation code in this customer controller. This is separation of concerns or MVC, so that's why this simply calls a method on another class that is dedicated to database access. So this is our insert customers method. It's fairly simple. All it does is it creates an array list of customers. And remember that customer is a JPA entity, Java Persistence API entity, and we actually generated this automatically in a previous lesson. We are going to insert new customers with new customer IDs. So this first new ID is the first ID that we're going to insert. Temp customer, we're going to use that later in this method. Now this class has a couple of fields that are not null and that are actually foreign keys pointing to other tables. So we need to populate those, and that's the purpose of these two other. These are JPA entities that we're going to use to populate those required fields. Now in this loop, we actually create the new customer and it is in memory. So simply set temp customer to a new customer object and set its properties. We set the ID to the first new ID, and let's change this to first new ID -1 because at this point that value will be already incremented, so we want these two to match. So we set the name, just a temporary name, set the discount code and zip to these two entities here, and then add to the list. NetBeans is giving me an error. I need to put this in parentheses. Then the error will go away. Okay. So as we go through the loop, we populate the list with customers, and at this point, they're still in memory. They're not in the database yet. So then we have another loop that will actually insert these customers into the database. As we can see, this calls the create method. Remember, this customer facade was originally generated by NetBeans. We've been adding methods as we need them, but it has methods that do CRUD operations: create, read, update, and delete. So let's take a look at the create method. Remember, we didn't write this. It was generated by NetBeans. And all it does is invoke an entity manager to get an entity manager instance. And remember, entity manager is an interface provided by the JPA API. And that invokes persist. And whatever entity or JPA entity is passed is saved into the database at this point. So we're calling this in a loop. So at this point, we insert the 3 new customer objects into the database. So before invoking that code, we can see the data in the customer database. So we can right click here on databases, tables, app tables, and customer, and say view data, and let's sort by customer ID, and see that the last ID here is 863. We're going to insert a few more that start with 901. So we should see a few more when we run this. Let's go ahead. Let's actually reload and click here. Okay. Now if we go back here and refresh, here are the 3 temporary customers that we just added. Okay, and notice that other than these fields here, everything is null. So we're going to update these fields. We're actually going to add a city. So when we update, we'll see a value here. Okay, so let's go back to the code. If we look at the JSF markup, here's our markup for update temporary customers. That invokes the update temporary customers on the controller. And again, it invokes a method on the facade or DAO. Okay, so here we see JPQL, and this is a JPQL update statement. If you are familiar with SQL, this will look very similar. Just like we discussed before, JPQL, instead of dealing with database tables directly, it deals with JPA entities. So what we see here, I would like to mention before moving on that JPQL is case insensitive. However, just actually by convention, I put all the JPA keywords in all caps. I missed one here, that's why I just fixed. So this, we update the customer entity, set its city attribute to Washington, where name starts with or is like temporary. And this is start with because we just have a plain string here, and then we have a % here. So that means any string after that will match. So all the rows whose names start with temporary will be updated. Again, if you're familiar with SQL, this should be no surprise. It works the same way. So that's our string, our query. Then we need to instantiate a query object, and we do that by invoking create query on entity manager and pass the JPA query as a string. And then finally, we invoke execute update on that query object, and at this point, the database is updated. Okay, so let's go back to the browser. Let's hit back, let's hit reload for good measure, and let's click on update temporary customers. So if we go back to our customer list here, the table, and refresh, now all of the new temporary customers have a city. So there you have it. If you need more information about word clauses and what have you, there is plenty of information on the web, or you can check my NetBeans Java IDE book. Unfortunately, we don't have the time to cover everything in detail here, but that will give you a good idea to get started with updating data with JPQL. So that's it for this lesson. I'll see you guys in the next lesson. Welcome back. In this section, we are going to continue talking about the Java Persistence Query Language, or JPQL. And there's only one topic that we're going to cover, and that is how to delete data with JPQL. Okay, as you guys may remember, in the previous section, we added some code to insert and update some data using JPQL. We added 3 temporary customers. to the customer table so we can still see them here in the database. Now we are going to add some code to delete this temporary customers. So our JSF page, very simple. We're going to add a command button that deletes the customers, and this invokes a method. When the user clicks on the button, invokes the delete temporary customers method on our controller. And remember, this is controller as in the C in MVC pattern, so it does not deal with database access directly. That is taken care of by a DAO, a data access object, or a facade, which is what NetBeans calls them. So this method calls the delete customers and customer facade, delete customers method. Okay, so here we have our JPQL. Those of you that are familiar with SQL will see that this is very similar. We have delete from, then customer is our JPA entity. We don't use the table name, we use the name of the entity, which is the name of the class. C is an alias. We have our where clause. If we don't use a where clause, then all the data in that table will be deleted, which is not what we want. And the where clause works just like we've seen before. In this case, we want to delete all of the rows or entities whose names start with temporary. So we use the like operator, temporary, and then just like in SQL, we have a percentage sign, which means anything that starts with temporary. Okay, so this is just a string, regular Java string, nothing fancy. So with that, we need to create a query object just like before. So we invoke create query on entity manager and pass our string. And then once we have our query object, we invoke execute update, and then the actual deletion is done in the database. Okay, so let's see it in action. Okay, here we have our third button. Once we click it, immediately those temporary customers will be deleted. So let's go ahead and click. Okay, we have our confirmation message. Let's go back to the database. And if we refresh, the temporary customers are gone. So as we can see, we can easily delete rows from the database using JPQL. Since most Java developers are familiar with SQL, the syntax is very similar. So that's it for this lesson, and that's it for JPQL. In the next lesson, we will be talking about the criteria API, which is a way to create queries, JPA queries, using a Java API as opposed to a query language. So see you guys in the next lesson. Welcome back. In this section, we are going to talk about JPQL name queries. So what are name queries? Well, in most applications, we want to use JPQL queries multiple times. So the normal way, so to speak, of using JPQL queries that we've seen before, we just declare them as a string. And potentially we will have to declare the same string over and over. So JPQL name queries allow us to declare the queries in one place and then just access them as needed throughout our application. We'll see how to declare name queries using the name query annotation, and then we'll see how we can use them in our application. Here we have the project that we've been working on in this section, and when we had the queries or the JPQL or the JPA entities generated, NetBeans generated a number of name queries out of the bat. So it creates one for each property in the entity. So there's a property called customer ID, so it creates a customer.findByCustomerID query, and then the actual query. And then by convention, the query name should be preceded by the name of the entity class, dot, and then the name of the query. And we declare them. This was done automatically by NetBeans, but if we're going to do it by hand, we declare them by using the name query annotation, has a name attribute, and that has the name of the query, and then it has a query attribute when we actually specify the JPQL query. Now, if we have more than one query, just like we have here, we should enclose the name query annotation in a name queries annotation, which takes an array of name query annotations as its sole attribute. Okay, so this is how we declare them. This was done automatically by NetBeans, but if we were to create one by hand, this is what we would do as well. Okay, so how do we access these queries once we have them? Well, in our previous examples, we created this getCustomer JPQL. Let's go ahead and write an equivalent method that instead of using JPQL directly uses a name query. Notice that this query here is the same as this query here. So we're going to write some client code that uses this name query to get equivalent functionality. Okay, so let's leave that method alone. Let's create a new method. Customer. Customer ID. Okay, so in this case, we're not going to declare a string like before. We're going to use a name query. So we still need the query interface. em.create name query. And one nice thing about NetBeans is that it's context aware. It knows that we're going to use one of the name queries already declared, so we can type in the first few characters, hit Control Space, and it completes. The one that we want is findByCustomerID. Okay, so now that we have a query object, just like before, the rest of the code is exactly the same. In this case, the name of the parameter is different, but the actual code mechanism is all the same. So let's go ahead and set the parameter value. In this case, it's customer ID. Let's pass customer ID, which is this parameter that we receive. Get the result. Get single result and return the result casted to the appropriate value. So that's our new method. Now let's change the controller so that it uses the new method. Not maximize that. Our getCustomer method calls getCustomer JPQL. Let's change that to call getCustomer name query. Okay, and recall that the JSF page invokes retrieve customer. Okay, which in turn calls getCustomer, which is the method that we just modified. So in the end, we're calling our new method. Okay, so let's go ahead and see the new code in action. Let's run our project. Okay, here's our project, and the page that we want is customer ID input. We enter an ID, and we get information for the corresponding customer. Okay, so as we can see, working with name queries is no big deal. It does provide the advantage that we can declare all of our queries in one place. By convention, we want them in the same JPA entity that the query deals with. And again, by convention, the name of the query should be prefixed by the JPA entity name. So that's it for this lesson. See you guys in the next lesson. Welcome back. In this section, we are going to be talking about the NetBeans JPQL editor. So far, we've been writing JPQL queries either by hand or just letting NetBeans generate them when we generate our JPA entities. NetBeans has a very nice JPQL editor that allows us to test our queries before we put them in our code, and it has code completion and all that good stuff. So we'll see first how to find it. It's kind of hidden, and we'll see how we can run JPQL queries. And another nice feature is that we can view the generated SQL. The way JPA works is it turns both JPQL or the JPA API into SQL behind the scenes, and that's what the database understands. So the editor allows us to view that generated SQL. Okay, so first, how do we find the editor? It is kind of hidden. If we expand here configuration files on our project, then click on persistence.xml, right click, and then click on run JPQL query. That's when we are able to open the editor. If we hit Control Space right off the bat, we can see that we can either delete from, select, or update using JPQL. So let's do a quick select. Control Space complete. Actually, let's just not use the word close right now. Let's just run that. Okay, so here are our customers. Remember in a previous lesson, we have written some code to insert some temporary customers, and we later deleted them. I actually re-added them just so that I can demonstrate with these as opposed to the data that comes in the sample database. I want to leave that alone. So let's say we only want to see the temporary customers. We can add a where clause. Control space, C dot, control space again, name, use the like operand. Anything that starts with temporary, click here to run it, and now we only see our temporary customers. Okay, so let's say that we want to add a city to these customers, and let's assume for the example's sake that they all belong to the same city. Let's delete that. We can use an update. Customer C, set C dot city equals to, or C dot name, like temporary, and then run that. Okay, and let's select again. Okay, so here we see that the rows have been updated. I mentioned during the intro that we can see the generated SQL. We can do that by simply clicking on this tab here. And in this case, it's very simple. It's just a simple select. Those of you that are familiar with SQL should have no trouble understanding this. Okay, and finally, let's demonstrate how we can delete data. Or C.name. Run that. Okay, now let's see the SQL. See? And again, let's do the select one last time. Run that. And our temporary customers are gone. So as you guys can see, this JPQL editor is actually very handy with code completion. It allows us to very quickly test our queries before we put them in our code. Once we have them, we can just copy and paste them, add them to a name query, or just as regular JPQL queries. So that's it for this lesson. I'll see you guys in the next lesson. Welcome back. In this section, we are going to talk about the Java Persistence API, the Criteria API in JPA. We're going to look at two topics. First, we're going to see how we can select data using the JPA Criteria API. And then we'll see how we can pass parameters to the Criteria API query so we can filter the data that we get. Okay, so here we have a new method. This method is equivalent to the getAllCustomers method that we had before, but we've rewritten it to use the Criteria API instead of JPA. So to use the Criteria API, we need to get an instance of Criteria Builder from the Entity Manager by invoking the getCriteriaBuilder method. And then from that, we invoke the createQuery method on a Criteria Builder and pass the class of the JPA entity that we will be working with. In our case, it's the customer class. So that returns an instance of criteria query, and this uses generic. In our case, this criteria query is of type customer. In general, it will be of the JPA entity that we want to use. So once we have our criteria query, we invoke the from method on it, and this is equivalent to the from statement in JPQL or SQL. And again, pass the JPA entity class, and then this returns an instance of a class implementing the root interface. And again, heavy use of generics, so in this case it's of type customer. In general, it will be the JPA entity that we are using for our query. So once we have our root instance, we invoke select. And this is equivalent to select star from customer in SQL or select C from customer C in JPQL. And we invoke the select method. This returns an instance of criteria query again and assigns behind the scenes the value to this instance of criteria query so that way we can nest methods. So once we have our criteria query, we invoke createQuery on Entity Manager and pass the criteria query, and that returns an instance of type query, again using generics. At this point, our type query has a getResult list, just like the one we saw before. It returns a list of our entity object, in our case customer. So in our method, we just return that list and we're done. And this is the main place where we change the application. This method is called from the JPA controller. So if we click on Find Usages, we can see here the getAllCustomer methods change. It now calls getAllCustomers Criteria API. Now the rest of the application hasn't changed. This method is being called from the customer list JSF page right here. The implementation behind the scenes of the DAO is different. But once we run the code, the output is exactly the same, just like we've seen before. This is it. If we reload, we'll see it again. It's the same thing. So it's exactly the same. What we changed was the implementation to use the criteria API as opposed to JPQL. Now all of this is fine and dandy if we want to retrieve all of the instances in the database, but what if we only want to retrieve one or only a few? Of course, in JPQL we have where clauses, and there's something similar with the criteria API. In this case, we have a getCustomerCriteria API method, which is equivalent to the getCustomer method we had before. And all of this code is the same we've seen before. At this point, we want to pass a parameter. So we need an instance of parameter expression, which we obtain from criteria builder, parameter method, and then pass the class of the type of the parameter. In this case, we want an integer. It's going to be the customer ID. So our parameter expression uses generic. It's of type integer. Now here we have our select, and remember I mentioned we can chain method calls. So select root returns criteria query and assigns that to this object automatically. And then we call the where method, which again does the same thing. Criteria builder equals, and then root is our root here. Customer ID is the name of the property that we want to assign the parameter to. And then parameter expression is the one that we created here. Okay, so at this point, we're passing a parameter or creating a parameter for the query. Here we have our type query like before, but before invoking, in this case, get single results, so we get the results back, we set the parameter to a value. In this case, is the customer ID that we get as a parameter in our method. And just like before, the rest of the code didn't change that much. In the controller, the getCustomer method, we changed it to invoke our new method. And again, the result is equivalent to the JPQL version. And the rest of the code stayed the same. We have a customer ID input that, well, invokes retrieve customer, which in turn calls getCustomer, and then that calls the method that we were just discussing. So when we deploy, the code or the output looks just like before. If we enter an ID and hit submit, we get the data for the ID that we entered. So that's it for the criteria API. It provides an alternate method or alternate way of selecting data from the database. Instead of using JPQL, we can use the criteria API and build queries using Java code as opposed to JPQL. So that's it for JPA. In the next lesson, we'll be talking about EJBs, specifically session beans. So I'll see you guys there. Welcome. In this section, we are going to talk about session beans. Session beans are a type of enterprise Java bean, or EJB. EJBs are server-side components that allow us as application developers to focus on writing and developing the business logic. EJBs take care of enterprise application requirements such as transactions, security, scalability, so on and so forth. So we don't have to implement those things over and over. They are provided by the application server. Specifically, session beans are meant to code the business logic, and they are frequently used as DAOs as well, the DAO design pattern that we've already seen. There are two types of session beans, stateful and stateless. The difference being that stateful session beans maintain conversational state across method calls between the client and the bean, where stateless beans do not. Conversational state, that's just a fancy way of saying that any instance variables in the EJB are guaranteed to retain their value across method calls for stateful session beans, and this is not the case for stateless session beans. Stateless session beans perform better, so that's why they have this limitation that conversational state is potentially lost across method invocations. So we'll see how to implement a session bean, and then we'll see what we had to do from the client to invoke a method in our session bean. So let's get to it. So here we have a stateless session bean. As we can see, there is nothing out of the ordinary in this code. This is a standard Java class. The only difference between our EJB and any other classes is the stateless annotation. Stateless annotation marks this class as a stateless session bean. If we wanted a stateful session bean, we could use the stateful annotation, and that will be it. Actually, for this example, let's keep it stateless. Okay, so we have a single method, say hello. It's a hello world. It's a very simple example, just returns the string hello world. So our bean, our code is extremely simple. Now here we have a JSF controller that invokes a method on our session bean. Here we have instance variable of type hello session bean, which is the bean that we just saw. Notice that it is annotated with the @EJB annotation, and what this does is it allows the application server to provide us with an instance of the session bean. Notice that we never instantiate the session bean. You don't see a new session bean equals, new instance anywhere. We just use the annotation. An instance is provided by the application server. Here we have an init method that is annotated with post construct. What this does is this method is invoked automatically by the application server when our controller bean is instantiated. And what we're doing here is setting the greeting variable to the return value of the say hello method in our session bean, which remember is hard-coded to hello world. Okay, so other than that, we just have an empty constructor and getter and setter. Very simple stuff. Notice that this is a JSF-managed bean. So the next piece of the puzzle is an faceless page, XHTML, that invokes the get greeting getter from our JSF-managed bean. And we do that with the expression language right here. So when we run, we will have a very simple page that says session bean says hello world. So let's go ahead and actually run the application. Process coming up. And here it is. Session bean says hello world. So as we can see, implementing a session bean, it is very simple, and they provide a lot of benefits such as transaction handling and scalability. And we don't have to worry about them. We just write our code just like we always do and add the stateless or stateful annotation. We have a degree of control of how transactions are handled. So we'll talk about that a little bit in the next lesson. But that's it for now. See you guys in the next lesson. Welcome back. In this section, we are going to continue talking about session beans. The specific topic of this section is transaction management with session beans. Enterprise Java beans and session beans in particular are transactional, meaning that all of the steps on a method are executed, or if anything fails, if an exception is thrown, the whole thing is rolled back. The EJB specification provides transaction attribute annotation that allows us to configure the behavior of the session bean when one of its methods is invoked while a transaction is in progress, and again how to behave while no transaction is in progress. Before moving on, I would like to mention that in this section this is going to be a little different from other sections in which we're going to mostly look at slides with very little code, because this transaction management, all of it happens behind the scenes, but there's not a whole lot that we can demonstrate, via GUI and behavior and what have you. So having said that, let's continue. Like I was saying, the transaction attribute annotation controls how an EJB behaves when one of its methods is invoked while a transaction is in progress. We can annotate the EJB at the class level using the transaction attribute annotation, and if we do that, the annotation applies to all of the methods in the class. And we can also annotate individual methods, and then in this case the annotation only applies to the method that's being annotated. If we have the transaction attribute annotation both at the class level and at the method level, then the method level one wins or takes precedence, since that one is the more specific one of the two of them. And here we have the different values that we can add to the annotation and a brief explanation on how the method will behave both when a transaction is in progress and when no transaction is in progress. We can specify that a transaction is mandatory. If we do this and invoke the method while a transaction is in progress, then the method becomes part of the existing transaction, becomes part of a bigger transaction that's already in progress. If no transaction is in progress, then an exception is thrown. Okay? We can also specify a value of never. In this case, if a transaction is in progress when the method is invoked, a remote exception is thrown. Otherwise, the method is executed, no transaction support. We can say that transactions are not supported. So in this case, this is a little different than never. If we invoke this method while a transaction is already in progress, the existing transaction is suspended. Then this particular method is invoked without transaction support, and after the method finishes, the original transaction is restarted or resumed. And if no transaction is in progress, then the method is executed without any transaction support. Okay, the next value that we can use is required. In this case, if a transaction is in progress, then the method becomes part of the existing transaction. Otherwise, a new transaction is created for our method. We can say that our method requires a new transaction. So in this case, if a transaction is already in progress, that transaction is temporarily suspended. A new transaction is created for our method. Then after our method finishes, the original transaction resumes. If no transaction is in progress, then in this case, a new transaction is created for our method. Finally, we can say that our method supports transactions. In this case, if a transaction is in progress, our method becomes part of the existing transaction. Otherwise, the method is executed without any transaction support. One more thing that I would like to mention is that the default value, if we don't specify the transaction attribute annotation, the default is required. So if we don't say anything, this is the one that gets assigned by default. So as far as code, there's really not that much to show. Here we have our simple example from the last section. If we add the transaction attribute annotation, we can add any one of the values that we just discussed. So let's say, for example, requires new. In this case, then all of the methods in the bean will have a requires new annotation. In this case, we only have one, but if we have multiple, they will just pretty much inherit this value. And again, we can use the annotation at the method level and assign a different value, or the same one, but the same one will be redundant. Let's say required, and in this case, this annotation takes precedence of the one at the class level. And then when we run our session, meaning our method is executed, the transaction management will behave as described on the tables that we just saw. So that's it for transaction management and EJBs. See you guys in the next section. Welcome back. In this section, we are going to continue talking about session beans. Specifically, we will be talking about interceptors. What are interceptors? They are Java classes that allow us to do aspect-oriented programming when using EJBs. And what is aspect-oriented programming? Well, it's a coding technique that allows us to implement cross-cutting concerns in a specific place. Cross-cutting concerns, an example of that will be, for example, let's say we want to add logging to an application and log whenever a method is invoked and whenever we're leaving a method. Traditionally, we will have to add a little bit of code at the beginning and end of that method. But with aspect-oriented programming, we can add the code in a central place and then just access it from every method. So it makes our code more maintainable. We will be talking about the around invoke annotation, which we need to use when we are developing an interceptor. And then we'll see the interceptors annotation, which we need to use on the EJBs that will be intercepted. So let's take a look at some code. Here we have an interceptor, and this is the example that I was just talking about, logging, adding an entry to a log file just before a method starts executing and right after. So this is our one method in our interceptor. Notice that it is annotated with around invoke. So that is a requirement for this method to be called at runtime when the client code is executed. The name of the method doesn't matter. We can name it whatever we want, whatever legal Java name we want. However, the method must be public. It must return object. It must take an instance of invocation context as a sole parameter, and it must throw exception. So those are the requirements. Okay, as for the method body, jump ahead a little bit. This call we see down here, invocation context.proceed, this is when the client method, the method that's being intercepted, will be invoked. So whatever code we want before this method is executed, we need to place before this call. So in this particular case, we're just using a system out print line to keep things simple, and we're just adding a login message saying entering, class name dot method name. And after the method is finished, we added some more code. So whatever we want after, we place after this method call. In this case, again, a simple system out print line, leaving, and this call gives us the class name, and this call gives us the method name. And we get that from here. Invocation context, notice that it comes as a parameter. If we invoke get target on it, we will get the object that has been intercepted. So from that object, we call getClass getName, and we'll get a user-friendly name. And then the method can be retrieved from invocation context.get method. Okay, so that's our interceptor. This is the hard work. Now, what do we need to do to actually have the code in the EJB intercepted? Here we have our session bean from our previous example. The only modification that we added to it was to add this interceptors annotation. And it takes as a parameter an array of interceptor classes. So in our case, we have only one, so login interceptor.class. But if we had more, we would just add them here. Interceptor, for example. So on and so forth, as many as we want. And they will all be called in turn. Okay? And this interceptor class can be used at the method level, just like we have here, in which case it applies to a single method, or we could have added it up here at the class level. In which case the interceptor would apply dot class to every method in the class. But this is just for demonstration purposes. Let's remove that out of there. Now let's go ahead and run the application. Right click on the project and click run. Okay, here we have our browser, and the output in the browser is exactly the same. Nothing has changed here. However, these logging entries, we can see them in the server output down here. So here we see entering, here's the class name and method name, hello session bean say hello, and leaving class name session name. So this entering message is the system out print line we see here, and this leaving message is the system out print line we see after calling invocation context.proceed. As we can see, adding aspect-oriented programming to EJBs with interceptors is actually very easy, no big deal. All we need to do is write an interceptor with one method with the signature annotated with a round invoke, then use the interceptors annotation either at the class level or method level, and that's it. Okay, so that's it for this lesson. I'll see you guys in the next lesson. Welcome back. In this section, we're going to keep talking about session beans. Specifically, we are going to talk about the EJB timer service. The EJB timer service, what it does is that it allows one of the methods in our EJBs to be executed periodically without intervention. So for example, we can set a method to be executed every hour or once a day or every 2 hours, what have you. The possibilities are endless. Every minute, every second, every 30 seconds. We can pretty much set it any way we need to. To do this, all we need to do is annotate the method with the schedule annotation, add schedule. We'll discuss the syntax briefly, and we'll provide some resources for more information about the syntax. Okay, so here we have, this is a very simple EJB. It has only one method. This is a stateless session bean. By the way, it must be a stateless session bean for the timer service to work. The method that we want to execute periodically must be public, return void, and take no arguments. The actual name of the method doesn't matter. Now here's our schedule annotation. Has several attributes. Hour, if we say star or asterisk, that means executing every hour. Minute, again, every minute. And second, the syntax here means execute every 30 seconds. There's other attributes that we're not using, but we can take a look. Control space for completion. Day of month, we can specify a number from 1 through 31. Day of week, we can either say a number, 0 through 7, or actually the strings Monday, Tuesday, Wednesday, what have you. Info is used just to add some information about the timer. It can be any string. We can specify what month, and again we can use numbers or strings with names. Persistent. By default, all timers are persistent, and what that means is that if we shut down the server and then restart it, timer starts again. Or the server crashes and we restart it, the timer starts, so we never lose that. If we don't want that to happen, then we will set that to false. If we want to add time zone that is different from the default, we can specify it here. And then year, we can specify the same syntax that we saw before for hours, minutes, or seconds. Now, the syntax for these attributes are based on the cron Unix utility. So there are a couple of resources that I'd like to show before moving on. If we look at the Java doc for Java EE, we can see them online by going to docs.oracle.com/javaee/6/API and then look for the schedule annotation. We'll see some examples for the syntax. Like for example here 1 and 31 and so on and so forth, day of the month and what have you, or actually days of the week. So here we can see the syntax. We don't have time to go in detail, but that information is available online, so you guys can go on your own and take a look. Also, there is a very good introduction to the cron utility at www.unixgeeks.org/security/unix/cron-1.html. And this will explain the syntax as well. Remember I mentioned that the syntax of the schedule annotation is based on cron, so by reading this tutorial, we should be fairly good at that syntax and be able to set the timers any way that we need. Okay, so having said that, let's go ahead and deploy our application. If you just click run, it will get deployed. And then once it's deployed, we need to keep an eye on the Glassfish log, and we'll see the output log message method invoke at, and then it'll show the current date and time. Still deploying. Okay, it was deployed. Browser comes up, but we don't really care about it. It's just the default JSP that NetBeans creates. But here's the interesting stuff. Well, in 30 seconds, we'll see it in the log. Should be here any minute now. There we go. Log message method invoked at, and that's the current time I'm recording this. In 30 seconds, we'll see it again. So if we wait just a few more seconds, we will see the log entry once more. It's there, just have to scroll. So as we can see, setting up the timer service is very easy. All we have to do is use the schedule annotation, use cron syntax to specify how often the timer will fire, will go off, and the method will execute. So just with one little annotation, we can have this functionality and have automated methods that are called without intervention. Like for an example use for this would be email a report, every day or once a week, every month, whenever we need, and it will be done automatically without anybody having to manually invoke the code. So that's it for this lesson. We have one more lesson on EJBs. We'll see how to create EJBs from entities in the next, from JPA entities in the next lesson. So see you guys there.